The perimeter of a shape is the distance around it. The way that you find the perimeter is to add up all of the sides. The area of a shape is the amount of space in that shape. And the way that you calculate it is by using formulas that we're going to talk about. There are three main formulas that we're going to focus on, and they are the formulas for a triangle, rectangle, and square. The formula for a triangle is 1/2 base times height. There are two different types of triangles that you'll have to work with. There are right triangles and then there are non-right triangles. So for a right triangle, your base is one of your legs, and then the height is the other leg. Remember that in a right triangle, this side, the longest side, the one across from the right angle, is the hypotenuse. So your base and height are the other two. You could also have either an acute or an obtuse triangle. It doesn't matter which one. And in that case, you need a height. So this bottom distance here would be your base, but then you would have to start at your top corner and drop down a perpendicular line, and that would be your height. For a rectangle, the formula is length times width. And if we draw a picture of a rectangle down here, remember that it has two sets of sides that are congruent, that are and opposite from each other. So you can use one of each as your length and your width. The square formula is the same. The only catch is that the formula for a square looks the same, but your length and your width are actually the same. So I'm going to put a little star here. Since length and width are equal in a square, what it really means is that your area is actually whatever your side length is squared. This first example asks us to find the perimeter and area of a square with the given sides. So I'm going to first draw a picture because I think it's helpful to see. Okay, and then I'm going to label A, B, C, D, and all four sides are the square root of 13. So to calculate the perimeter, we add up all the sides. So I'm going to add the square root of 13 times itself 4 times. When you add radicals, what you're really doing is adding the numbers or coefficients in front of each radical. So you can't see it, but it's like there's a 1 in front of all these radicals. So what you're really doing is adding up 1 plus 1 plus 1 plus 1, which is 4. And then the square root of 13 just tags along. It's like you're saying how many square root of 13s are being added together, and there are 4 of them. So this is your perimeter. For the area formula for a square is length times width. In this case, the length and width are the same. They're both the square root of 13. So you could write it out like this, or that's the same thing as the square root of 13 squared. Either way, your answer is just 13 because the square and the square root cancel each other out. Now we're going to find the perimeter and area of a triangle. So the first thing you have to worry about with these triangles is that when you're not given the points to graph, unless you are given a right triangle, it would be pretty difficult to figure out. So the first thing we need to do is double check that this is in fact a right triangle. So what I want to do is I want to check that Pythagorean theorem. So I want to check that c squared is equal to a squared plus b squared. So in order to do that, I know that these three sides that I was given, those are my a, b, and c. I think it's easier to see once we square them which one is our c value. So what we're going to do is square each of these values. So 2 square root 5, if you square it, you could put it into your calculator, or you can do it in your head. You get 20. 5 squared is 25. And then 3 root 5 squared is 45. So I'm going to put a star next to this one because that's my largest number. That means that's the number I'm going to plug in for c squared. So now I'm going to go back down here. Instead of c squared, I'm putting 45. And I want to know, is 45 equal to 20 plus 25? And it is. So what that means is that this is a right triangle. And that means that we'll be able to calculate the area of this, because we'll use the two legs of the triangle as our base and height. So for the perimeter, I'm going to draw a picture first. And I'm going to label my sides. My longest side is 3 root 5. And I know that's the longest side because when I squared it, it came out to be the biggest number. And that is side CT. So that means this has to be A. All right, side CA is 2 root 5. This is a right triangle. And then AT is 5. So for my perimeter, all I'm doing is adding up these three sides. So I'm going to have 2 root 5 plus 5 plus 3 root 5. Okay, again, we're adding some radicals here. In order to be able to add them together, they have to have the same exact radical. So I see that I have 2 root 5 and 3 root 5. Those both have the same radical. And then I have this 5 that's just kind of on its own. So what I'm going to be able to do now is add the ones that I underlined in blue. I'm going to add the outside numbers. So I have a 2 and a 3. When I add those, that gives me a 5. And then the square root of 5 tags along. So again, basically what I'm saying is that I have 5 square root of 5s. And then I also have this plus 5 that can't be added together because it doesn't have a matching radical. So that's my final answer for my perimeter. As far as area goes, the formula for the area of a triangle is 1/2 base times height. So if we go back down to our picture of the triangle at the bottom here, in a right triangle, the two legs of the triangle, so the ones that are not the hypotenuse, can be your base and height. So I like to use the bottom one as base and the side as the height. So when I plug these in, it would be 1/2, the base is 5, and the height is 2 square root 5. All right, now when you're multiplying radicals, there are some different rules here. When you multiply, you can multiply any numbers that are in the same spot. And what I mean by that is you can multiply any numbers that are not under a radical together, and you can multiply any numbers that are under a radical together. So I'm looking here and I see this 1/2, 5, and 2. Those are all numbers outside of a radical. And if I multiply all of those numbers together, I'm going to get a grand total of 5. And then I also have this square root of 5, which is the only radical. So basically it just tags along. So my answer for area is 5 square root 5. Now we're going to do a rectangle. So the first thing I'd like to do is draw the picture. I think that's really helpful to see. And let's see, my sides, or my corners are MATH. And then the long sides are 2 root 10. And the short sides are root 10. So for the perimeter, all I'm going to do is add up all of these side lengths. So the perimeter is going to be 2 root 10 plus root 10 plus 2 root 10 plus root 10. So really the question here is how many root 10s do I have? So I'm going to put in these invisible ones again. So if you add up 2 plus 1 plus 2 plus 1, it gives you a grand total of 6. And then you have this square root 10 that tags along with your final answer. So that's your perimeter. For area, the formula is length times width. And if you go down to our picture, as long as you pick one of each side, it doesn't really matter which one is which, but I'm going to label my length as the square root of 10 and then width as 2 square root 10. So again, remember that you can multiply numbers that are in the same place. So I see that I only have one number that's not under a radical, and that is the number 2. And then if I multiply my radicals together, if I do the square root of 10 times the square root of 10, that's actually the square root of 100, which is a perfect square. So that just turns into 10. And if you think about it, it kind of makes sense because it's really what you're doing is the square root of 10 squared. And that's one of those where the radical and the square cancel each other out. So back to what we were doing. This is really just 2 times 10 or 20. And if you typed this part right here, if you typed that whole thing into your calculator, it would give you 20 right off the bat. These problems are a little bit more involved. We are going to do the exact same thing we just finished doing, but now we have an extra step before we get to that part. And the extra step is that we actually have to calculate all the distances before we can move forward. So this one is 3 vertices. That means we're going to be graphing a triangle. So the first thing we want to do is graph those. So I'm going to go to 3, 3, and I'm going to label my points. 6, negative 3. And then negative 4, negative 3. Okay, so here's my triangle. And now we need all 3 side lengths. And to find the side lengths, we're going to use the distance formula. So I'm going to write this up at the top here. Just a friendly reminder that this is a formula you will have to have memorized for the test. Okay, now one thing to notice, it's always good to find shortcuts if they will make your life easier. If you look at the bottom side, so the side that's horizontal, if you have an exactly horizontal line or an exactly vertical line, instead of doing the distance formula, you can just simply count the number of boxes from each point. So if I count from negative 4, 3 to 6, negative 3, it's a total of 10 boxes. So rather than calculating the distance formula, it's a lot faster to just count and see that it's 10. All right, but the other 2, unfortunately, we're going to have to do the long way. So we're going to have to do the distance between the points negative 4, negative 3, and 3, 3. And then we're also going to have to do the distances between 3, 3, and 6, negative 3. Okay, so for the distance formula, I'm going to plug in these points. I like to set up my formula. All right, so now I'm going to have 3 minus negative 4 and 3 minus negative 3. And when you plug this in to your calculator, it would be, let's see, 49 plus 36. So you get 85. So that means this distance right here is the square root of 85. Now one thing I need to mention is that if it's possible that it can be broken down by using a factor tree, that's something that you need to do. But if you break down 85, it turns out to be 17 times 5. And that's as far as you can break those numbers down. And since there aren't any pairs, that's how our answer will remain, is the square root of 85. For the second one here, I would have 6 minus 3 and negative 3 minus 3. And when you put that into your calculator, you're going to get the square root of 45. If I break down 45, it's 9 times 5. And then 9 is 3 times 3. So this one I do have a pair of 3's. That means my final answer would be 3 square root 5. The reason that this is important to break down the numbers is because sometimes you'll see that the radicals look different at first, but when you simplify them, they are actually like radicals. So when you do your perimeter, they would actually add together. So it'll change the way your answer looks. Okay, so that was the extra step. Now we have to go back to what we were doing and figure out perimeter and area. So for perimeter, all I'm going to do is add my 3 numbers. So 10 plus the square root of 85 plus 3 root 5. I have nothing that can be combined. So even though it looks nasty, that's our answer. Can't do anything else with it. And then for area, remember that our formula is 1/2 base times height. I have a base. I know that the base is 10, but I don't have a height yet. And you can do the work really quick to see that this is not a right triangle. My C value would be 10, so this would be 10 squared, and then the square root of 85 squared, plus, I'm going to leave it as the square root of 45 squared for now, just because it'll make my life a little easier. So you can see that 85 plus 45, which is 130, is not equal to 100. So this is not a right triangle. But what you can do, if you take this top corner of your triangle and you drop straight down to that bottom horizontal part of your triangle, that is a height. And you can count the boxes. It's actually 6. So that's going to be the height of our triangle. And then if you do half of 10 times 6, you end up with 30. So 30 would be the area of this triangle. All right, so now we need to find perimeter and area of another triangle. And then we're going to do a rectangle. And I think you'll see that actually rectangle, while it seems like it would be more work, is actually less work than the triangles. So the first thing we need to do is graph all of our points. So I have 1, 3, 3, negative 2, and negative 2, negative 4. And now I need to calculate my distances. Unfortunately, I don't get to do any shortcuts because I don't have any horizontal lines or vertical lines. They're all diagonals. So we are going to have to do the distance formula 3 times. So let's start with negative 2, negative 4, 2, 1, 3. So my distance formula would look like this. I would have 1 minus negative 2 and 3 minus negative 4. So that would be 9 plus 49, or 58. And then again, you have to break down any radicals that you can, but if you break down the square root of 58, it's 2 times 29. There's nothing else you can do there. So we get to leave this one as the square root of 58. Okay, next one. Let's do the points 1, 3, and 3, negative 2. So I have my formula here. All right, so I would have 3 minus 1 and negative 2 minus 3. So that would be 4 plus 25, or 29. Okay, 29, there's nothing we can do, so we get to leave it how it is. And then our last set of points, from the point 3, negative 2 to negative 2, negative 4. All right, so I would have negative 2 minus 3 and negative 4 minus negative 2. So that would be 25 plus 4, so 29 again. Okay, so now I can't find, well, first of all, I'm getting ahead of myself. Let's do perimeter. So for perimeter, we're adding up all 3 sides. So I have the square root of 58 plus the square root of 29 plus the square root of 29. I have 2 square roots of 29, and they each have an invisible 1 in front. So my final answer would be the square root of 58 plus 2 square root 29. It, by the way, does not matter if I had put 2 square root 29 first or second. The order of your answer doesn't matter as long as each term is correct. For the area, I need a height. And if you notice, we can't draw in our height nicely like we did last time and be able to count the boxes. So let's check and see if this is a right triangle. So this one right here, the square root of 58, that would be C because it's the largest. So what I want to see is the square root of 58 squared equal to the square root of 29 squared plus the square root of 29 squared? So what I'm really asking is 58 equal to 29 plus 29? And if you put that into your calculator or if you add it in your head, it does come out to be equal. So what that means is that this is a right triangle. And when you have a right triangle, your base and your height are the two legs of your triangle. So I'm going to make those sides bold. So the two sides that are the square root of 29s, those are going to be the base and height that we're going to use for the area formula. So area is 1/2 base times height. So in this problem, it's 1/2 times the square root of 29 times the square root of 29. Remember that when you have the same radical multiplied by itself, the radical disappears, and what you end up with is half of just the number 29, no radical anymore, and then half of 29 is 14.5. So that would be the area of this triangle. All right, now let's do a rectangle. So we're going to plot our points first. 1, -4, 4, -2, -3, 2, and 0, 4. So now you can kind of see the rectangle. Now the nice thing about rectangles, and even nicer about squares, in a rectangle the opposite sides are the same length. So we only have to do the distance formula twice. One for the short side, one for the long side, and then the opposite sides of those will be the same length. In a square, you only have to do the distance formula one time because all four distances will be the same. So I'm going to choose to use the point that has 0 in it for both of my calculations because it just makes my life a little bit easier. So I'm going to use the point -3, 2 and the point 0, 4, and we'll do the distance here. Okay, so I would have 0 minus -3 and 4 minus 2. So we would get 9 plus 4, which is the square root of 13. So that means that both short sides are the square root of 13. Next we're going to do, I'm going to use the point 0, 4 and then 4, -2. And it doesn't matter which points you use, you'll get the same answer. I just know that when I plug 0 in, it makes my calculations a little bit easier. So that's why I like to choose the points that have 0. So I would have 4 minus 0 and -2 minus 4. So that would be 16 plus 36, or 52. And 52 I have to check to see if I can break this down. 52 is actually 4 times 13. And 4 is 2 times 2. So I have a pair of 2's. That means I can take out a 2 and then I would have a 13 left over. So I think I mentioned this in the previous slide. The reason you have to break down all your radicals if you can is because when you look at the square root of 13, you look at the square root of 13 and the square root of 52, they don't look like you could add them together. But when you break down the square root of 52, you see that they actually can be added together. So if you didn't break down that radical, your perimeter answer would look wrong. All right, so let me put in these distances, and then we'll calculate area and perimeter, and we'll be done. All right, for perimeter, I'm adding up all four sides, so the square root of 13 plus 2 square root 13 plus the square root of 13 plus 2 square root 13. So again, what I'm really doing is adding up all of the, how many square root of 13s do I have? So we're looking at all the numbers in front. 1 plus 2 plus 1 plus 2 would give you a grand total of 6 square root of 13s. For the area, the formula for the area of a rectangle is length times width. So I would take the length, which it doesn't matter which one is which. Let's make it 2 square root 13. So I take the 2 square root of 13 and I multiply it by the width, which is the square root of 13. Remember that when you have two identical square roots being multiplied, the square roots disappear and it just turns into whatever the number was. So really it's 2 times 13, or 26 for final answer of area.